to do some lower and upper sums to approximate the area under a curve. So first we're going to put our function in. X equals negative 0.5x cubed plus 2x squared minus x plus 1. Alright, so here's our function. And what we're going to do is we're going to set a couple points because we can find the area from here to here between the function and the x-axis, but we could go an infinite amount of space here. So we're going to set 2 points where we're going to find the area between those points under the curve. So we're going to go over to our graphics view. We're going to set point A there. We'll say point B right there. Alright, and then we're going to create a slider. We'll say put it right here. We'll name it N. And we want to go from 1 to 50 with the increment of 1. And we're going to try a vertical one just because. Alright, and then we'll hit OK. And then we got our slider. Right now, let's go ahead and click our cursor. It's going to go to 1 to 50, but as you can see, it doesn't do anything because we don't have N defined anywhere yet. So we're going to go back to the algebra view, and we're going to define an upper sum. Upper sum of the function between x is a and x is b, increments of n. So the upper sum is going to take this rectangle here. It's going to fit it, the top of the rectangle, to the highest point on the function within this rectangle. So in this case, it's going to go all the way to the top point here. And if we move this up, the n now has purpose. This rectangle here, these are all equal width rectangles, so it's going to find the highest point between A and this fifth of the AB. So let's go back there, and we're going to also define the lower sum. So we'll do it this way at the top, and then we'll do one that goes to the lowest point, so we'll have another rectangle here. Function between x of a and x of b, with increments of n. So now you can see this rectangle goes up to the lowest point between A and B there. And then if we'll move it up, let's go to just 2. Between here and B, it's going to go up to there. And alright, so next what we want to do, and then let's go ahead and just do a little quick cleanup. As you can see, we got the lower sum and upper sum. They give values here. They're kind of in the way. And actually, if we hit this under Edit, we can hide those for now, which I think we don't really want right now, because we're going to go down to Media and put in some dynamic text. And we'll put it over here. So we'll start with upper sum equals, and then we'll go to Advanced, and we have some options down here. And if we go to Objects here, we're doing upper sum, so we'll match it with upper sum, which will take the information that we just hid on the graph. And we can see a preview. It just gives the value. And we can change, make them bold or italicized. If we go to latex formula, you can add in summations or integration formulas or all kinds of different things. But I think this is all we need, so we'll hit OK, and we'll blow it up, or pop it up there. Then we'll do one for the lower sum. Go down to Advanced, Objects, and Lower Sum. And we can move it around a little bit how we want. So now what we'll do is I'm going to input a couple bits here. We wanted to find DIFF as the difference, and the difference is going to be the difference between the upper sum and the lower sum. Upper sum minus the lower sum, and it'll give us that value there, and we will see how that plays in a minute. And then we'll go ahead and add in integral f, the function f, between x at a and xb. Alright, so go back to the graphics view. We're going to insert some more dynamic text. We'll put it right underneath. For this one we want to define, or we want to use, we're going to call it difference, if I can spell, equals, and then we'll come down here to the objects and we'll use diff. What we have defined is the difference, and it'll show it here. Okay. Let's go ahead and clean it up just a touch, make it give a little more space. And then what we're going to do, well, let's go ahead and look at what we have here first. And then we'll add in the integral. Right now, you hit the cursor. Basically what we're trying to do is find the area underneath this curve between A and B. We can approximate it using rectangles. Right now the approximation is not going to be very good. As you can see, all this space here is above, which we're using in our calculations, but it's obviously not below the curve. And then the opposite of it, you get all this space here for the lower sum that we are not factoring into our calculation. But as we add more and more and more triangles, you see we'll still have some space that's above that we're using for the upper sum, and some below that we're using, or we're not using, for the lower sum. But you can see it's a lot smaller space, and that's indicated in our calculations here. Upper sum is 6.3 and lower 5.9. So they're getting a lot closer together, and the difference, we basically want the difference to go to 0. And as we get closer and closer, you can see the values of the upper and lower sums are a lot closer, and we're at 0.17 difference. So it's a lot closer approximation to the area under the curve because we're using so many rectangles. Now, what is the point of this? Is to show what we're doing in integration. Basic integration is actually, the idea is pretty simple. You're using tons and tons of little rectangles to get the area underneath the curve, maybe between two curves or whatever it is, but you're using so many that you're approaching infinity. So let's go ahead and put the integral number on here. We want to call it integral equals, and we'll go down to advanced and big F. Okay. And go back to the cursor so we're not popping up a bunch of different dialog boxes. So, as you can see, as we start at 1, we're quite a bit off of what the area is. And as we get closer and closer to in this case 50, we're getting a whole lot closer. The integral is 6.137, 6.05,